Alright, welcome back Math 12s. Today we're going to take a look at section 5.4 and we're going to work out the your turn from each of the examples in our chapter textbook. So the first example had a question that said determine the solutions for the trig equation for sine x squared minus 3 is equal to 0. So notice here I call this sine x squared. It's the sine of x all squared. So we're going to look for all the solutions where x is greater than or equal to 0 and less than or equal to 360 degrees. To solve something like this, we want to isolate sine x. And like we've done with other equations, things like, if you look over on the right here, for x squared minus 3 is equal to 0, we isolate the x by adding 3 to both sides and dividing both sides by 4. And then taking the square root of both sides to get x is equal to the positive or negative square root of 3 over 4. We're going to do the same thing with this trig equation. We'll add 3. We'll divide both sides by 4. We'll take the square root of both sides. And we'll simplify if possible, and we notice that we get sine of x is equal to positive or negative square root of 3 over 2. Now that should give us pause as we recognize those numbers as coming from our special triangles. If you recall, our special triangle is 1, 2, and root 3. And in degrees, because we're looking at degrees over here, this is 60 and 30. And of course 90 in the corner. So if sine of x is root 3 over 2, that means the opposite is root 3, the hypotenuse is 2, so we must be talking about an angle of x that's equal to 60 degrees. So we can say that our reference angle, or theta ref, is equal to 60 degrees. Now, sine is positive in the first and second quadrant, and it's negative in the third and fourth quadrant. Okay, positive and negative. So that means we're looking at 4 different answers. 2 for the first 2 quadrants and 2 in the other 2 quadrants. So in quadrant 1 we've got 60 degrees. In quadrant 2, 180 minus 60 is 120 degrees. In quadrant 3, 180 plus 60 is 240 degrees. And in quadrant 4, 360 minus 60 is 300 degrees. Okay, so our reference angle was theta, or x, I guess. But all of our x values in Q1, those are all our solutions. Now in example 2, we're asked to find the general solutions. So the general solutions for 10 is equal to 6 sine pi over 4 times x plus 8. Again, it can be useful for us here to get sine of pi over 4x isolated. So if we start with our equation, I'm going to subtract 8 from both sides to get 2 is equal to 6 sine pi over 4 times x. And then I'll divide both sides by 6 to get 2 over 6, or 1/3, equal to sine of pi over 4 times x. So the sine of something, the sine of pi over 4 times x, is equal to 1/3. Now 1/3 doesn't fit with our special triangles, so I'm going to use inverse sine of both sides to figure out what the angle is. If I take the inverse sine of 1/3, that should be equal to pi over 4 times x. Well, the inverse sine of 1 over 3, I'm going to need my calculator to do that. So the inverse sine of 1 over 3, making sure that I'm in radians here because we're talking about pi over 4. So I'll just check my mode, and sure enough, we're in radians. So the inverse sine of 1 over 3 comes in at 0.3398. So that means 0.3398 is equal to pi over 4 times x. Now I want to get x by itself. So how do I get rid of the pi over 4? We multiply by the reciprocal. We can divide by the fraction or multiply by the reciprocal. But whatever I do to one side, I must do to the other. So 4 and 4 cancel out, pi and pi cancel out, and that leaves us with x. 4 times 0.3398 divided by pi, we can do with the calculator, equals 0.4327. 0.4327. So that's what x is. But we're looking for a value of sine that's positive. And sine is positive in the first two quadrants. Right? So we have a value of x in the first quadrant. In the second quadrant, all right, I think we're good. So let's take a look at what I did here. So this is how I got to the proper solution. Let me work it through with you. So the first thing is that I know that sine is positive over here and over here, this angle and this angle. So whether I find the sine of pi over 4x or whether I find the sine of pi minus pi over 4x, I'm going to get the same sine value. So because sine is positive in the first quadrant and the second quadrant, I can either use my reference angle, pi over 4x, or I can go pi minus my reference angle. And that's going to give me the same sine values. So that's what I did. We already know over here that the inverse sine of 1/3 equals pi over 4x. That's right here. That means 0.3398 equals pi over 4x, and we figured out correctly that x was equal to 0.4327. So that deals with this one. My error was over here. It's not pi minus what x is. It's pi minus what the angle was to get 0.3398. Right? So pi minus pi over 4x equals 0.3398. Subtract pi from both sides. That means that's gone. And then we get 0.3398 minus pi is negative 2.802. Multiply by the reciprocal. Multiply this by 4 and divide by negative pi, and we get x equals 3.567, which was the answer that we knew it had to be from the graphing calculator. Now the question was about general solutions. And we wanted a general solution that would be the first two times in the period. So here's how I can write that now. I can say that x is equal to 0.4327 plus multiples of the period. And we saw up before that the period was 8. So multiples of the period, and x can also equal 3.567 plus multiples of the same period, and then I can say where n is an element of the set of integers. And that gives me all the possible solutions. If I go back to my graphing calculator and I look at my graph, my first point up here was 0.4367. If I add 8, this one should be 8.4, right? Because my period is 8. So let's just double check that. Second calc, number 5, we're going to move over along the straight line to save a little time. 6, you can see down the bottom left-hand corner, we're at 7, getting pretty close to 8. And if I hit enter, 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 8.437. Okay, exactly 8 more than this. So that bears out. We checked with our graphing calculator, but we solved it algebraically.